مساء الخير يا جماعة. نبدأ مع المحاضرة الأولى في الجزء الثاني من السيشن، والسبيكر عندنا اليوم المتحدثة سلمى باني، انجينير سلمى باني. She's a senior executive program planning, Ministry of Municipality and Urban Planning في البحرين. She is a BSc in Agriculture and a BSc in Agriculture, MSc in International Marketing and Purchasing, and pursuing her PhD in Sustainable Food Production System, worked with FAO and GTZ projects. Area of interests: food security, water management, and climate change impacts. She published quite few papers, and she won the Best Award Researcher Prize of Ministry of Municipality and Urban Planning in 2010. Salma, the floor is yours.
Bismillah ar-Rahman ar-Rahim. And I'm glad that I am not the first person who will talk about the food security. And I'm not talking about food security because it becomes something called a taboo to talk about food security as far as the Gulf is concerned. The reason behind of that, I had a bad experience in 1991 when I was studying my international marketing in Newcastle University. And there was a course called Food Aid. Then there was a question mark about the Common Agricultural Policy. How it's been created Common Agricultural Policy. And when there is a surplus, it's being dumped, that surplus, or destroyed by the cost of to save the farmers. And my question that time was, how about the poor farmers who are suffering and they don't have food? And they said that this is not our responsibility to feed them, because why they are fighting? Instead, why don't they grow? That was the simplest answer I got that time from the professor of the university. Again, when we come back to the point about why the Gulf, they are talking about food security when they have money and they can import. Importing full 100%, it's not a healthy issue. And every policy has a downtown. So there is no policy which everybody appreciates. When we come back to the point, even us, we have different perspective, different understanding, and different view of point. Even coming back to the point of the Gulf, each of country in the Gulf, we are united, but in the other way, because of everybody's capacity and circumstances, they have to do differently the way they do. But at the end of the day, it's the government responsibility to protect their people, and it's not healthy to be net importer anymore. Especially when 2005, 2008, the price crisis was there, and that's why, and now there is a big issue about land grabbing issue. Even when we change our attitude, saying that, okay, our country is not healthy to grow, and then we are going to find a land to help the people and help ourselves, and that was a question mark. Therefore, there is a policy need to be changed internationally, and there is a law and regulation should be applied. What I'm talking about today is that basic concept of sustainable food production system in Bahrain under the challenge of water scarcity, food security, and climate change. Sustainable food production, it's a complex issue, and it's interrelated system. It operates within the complex system, and it's multifunctional in its nature. For example, we cannot simply say that we wanted to grow without harming part of that complex system, such as delivering increased yield meets that the society other needs. What are the society other needs? Then this is what we are talking about. We are talking about the concept of economic, we are talking about the concept of social, and we are talking about the concept of the environment. As a definition, sustainable agriculture is defined as the ability of the farmland to produce food and other agricultural products to satisfy human needs indefinitely, as well as having sustainable impact on the broader environment. Again, The principle of sustainability, it implies that the use of resource. The resource what we need in order to grow. We need inputs such as land, water, and soil. And these three, we have the scarcity. Okay. Coming back to the point of water. The water is a one input which it cannot be renewable. That means the sustainability of water, there is a question mark. We have to think very seriously about this point. Due to the interconnectedness of the agricultural different rules and functions, there are many different difficulties in making sustainability operational. For example, dependency on non-renewable inputs such as water is unsustainable, even if the short term is necessary as part of both towards sustainability. And the big problem in the Gulf that we are facing is that we don't have rain, so totally we are dependent on irrigation, which means the groundwater. Then this is where the issue we have to consider. Therefore, how can we create more sustainable approach to agriculture while recognizing those wider and important social and economic parameters is the question we need to answer. This requires agriculture to avoid severe irreversible damage to the ecosystem service, such as soil fertility, water quantity and quality, and genetic variability. Following perspective are the issue that we have to consider, such as environmental sustainability, yield, production unit viability, product supply, equity, and so on. This is very simple diagram which shows us about the three parameters, which is the social, environmental, and economic, and how food production is interrelated in each aspect as far as it's concerned to the social and the climate and the economic. Therefore, the complex connection between water, food security, and climate change will create significant negative impact on food production and remains crucial policy issue. Therefore, we cannot say that business as usual. Therefore, we have to do something, and we have to think seriously. The aim of this paper is to review the role of the local production system in ensuring food security, with major emphasis on the approaches and the actions to be taken towards ensuring food security, as well as adaptation strategy in response to the water scarcity, climate change in the Kingdom of Bahrain. The biggest challenge in Bahrain and other Gulf countries are facing is limited agricultural land and shortage of water resource. Going to the limited agricultural land, Bahrain, it's a serious issue. Even we don't have a land to live. Therefore, we are looking for a land. Groundwater is the major resource of irrigation in Bahrain, as well as in the other Gulf country, because of the limited rainfall, which about 70 millimeters per year, and unavailability of the surface water. Therefore, unfortunately, the water allocated in agriculture, it's almost 80% of available water resource in the country, which is about 180 million cubic meter per year. The types of the irrigation system we use in the agriculture are traditional, drip irrigation, and modern irrigation in hydroponic system. Of course, the government provides subsidy in several ways. For example, the cost of the machinery service to the farmers, modern irrigation equipment, the prices for subsidies, prices for the plastic sheets, and the prices of veterinary drugs, as well as loans. And currently, we have a food security scheme, which it's a policy, a new scheme which supports the government supports small farmers in order to change the approach of producing it and advise them the best to do it in a very efficient and effective way related to the water and the land and the type of the product. Bahrain requires a reallocation of domestic resource in order to increase the agricultural production, lowering its food import, and boost the contribution of agricultural sector in its gross domestic product. Unfortunately, agriculture contributes right now 0.4 to Bahrain real GDP. Therefore, Bahrain remains heavily dependent on import to meet its domestic demand for most of agricultural products. We are saying one side, 80% of the water agriculture is using. On the other side, we are saying 0.4 only agriculture is contributing. So, where we can go there? We need a miracle to satisfy both sides, the water group, and to save our farms, and to feed our people. In order to address the growing demand and ever-increasing population combined with the scarcity of the natural resources, in particular water, and the world facing a perfect storm of food scarcity, Bahrain established food security scheme, as well as what we hear currently from the Qatar as well as Saudi Arabia. Our food security scheme is based on optimizing the exploitation of the agricultural land, empower farmers and grant them a land to boost the production, encourage agricultural investment, and optimize the role of the private sector in developing this sector. How it can be done that? To preserve the natural resource, to the present and the future generation, efforts being made in the agricultural sector. Adaptation to sustainable development agricultural policy is being carried out, promote and improved water use efficiency in agriculture, utilization of treated wastewater. However, the new policy and institutions are needed to be implemented sound, sustainable agricultural policy, such as water use development program should be adopted, production on certain strategic crops should be allowed, such as commodity that we have comparative advantage, and somehow we have to regulate the farmers selecting certain commodities which we know that it takes high water, that we shouldn't allow or make that a taboo to produce at all. Or saying that we are not going to provide any grants such that crops if you and also promoting utilization of the treated TSE. New policy and institutions needed to be implemented. For example, and as I said, production of certain strategic crops, promoting vertical intensifying and farming. So there was a study about the hydroponic method, and it's been discovered that it's the most efficient and effective way on our circumstance, but we need to educate our farmers. We need to make sure that we have all the equipment and the facilities. And currently there was just in the last 3 days ago, there was this area called Hur Ta'ali. It's been provided for farmers, 2 hectares, just to grow hydroponic products. And mainly they might grow to vegetables, because vegetables we discovered that we have a comparative advantage. In conclusion, the key element towards sustainable solution is fundamentally lies the way we are using and managing our resource in agricultural sector. Therefore, answer to the resolving issue of food security and stability in food production will increasingly come from improved water management and its sustainable use in agricultural sector. Thank you.
Thank you, Salma, for your nice presentation. We will be discussing all the presentation later on after the last speaker. And now Mr. Ali is going to introduce the second speaker for the session.
The second speaker will be Dr. Patrick Link. Dr. Patrick Link is a professor of the chemical engineering at Texas A&M University at Qatar, and the managing director and co-founder of the Qatar Sustainable Water and Energy Utilization Initiative, QWC as Center of Excellence for the Research and Capacity Building at Texas A&M. He currently leads the research into innovation, desalination, and process design with the focus on the membrane-based system and use of renewable form. Dr. Patrick, please.
That's it. Okay, thank you very much for the kind introduction. I will give a brief overview over the QNFSP water and energy dimensions, following from the keynote speech by Chairman Fahad Al-Attiyah. This slide was up here already this morning, so Qatar is under pressure, just as was also highlighted in the previous talk by from Bahrain, under food supply pressures, and this is a result of multiple reasons: water, land scarcity, and also then there is the uncertainty about impacts from climate change. In terms of domestic issues, there's a problem with water. So Qatar is a very water scarce country. Aquifers are depleting, so the rate of abstraction is higher than actually the rate of natural replenishment. There is relatively short water storage, and agricultural production is on the decline rather than on the up. If we look at water, there are basically three water sources in Qatar. The main one is desalination, which feeds into residential, commercial, government, and industry. There's the use of groundwater, which is used mainly in agriculture, and the TSE, which goes into agriculture as well as into greening the cities and a number of smaller uses. Just to give you an illustration, so this is how the groundwater has deteriorated over the years, so there's less and less good quality water available, and this is a cause of concern. In terms of the view of QNFSP, it has a number of dimensions, and water is a central dimension which then links into the provision of energy, since when we talk about water, we talk about desalination to a large extent. Now this water is then being used in agriculture and also in food processing. There are a number of underpinning pillars to be able to achieve sustainable development, and these relate to education, research, as well as the seeking of opportunity for economic diversification. If we look at the water management, the picture we have essentially is that most of the water is generated by seawater desalination. This is fed into a primary use, and then there is significant effort in Qatar to reuse the water, collect and reuse the water, and some of this treated sewage effluent is used in agriculture and to green cities. Now the groundwater is being used in agriculture, which is a cause of concern, and in terms of the QNFSP stance, the groundwater should be replenished rather than depleted. So there will be ban on the use of groundwater in agriculture, and instead desalination will be used to replenish the resource. There is a major project upcoming for aquifer storage and recharge, and this is to work towards the goal of stopping depletion of the aquifers and building up reserves and generally enhancing water security. The issue then becomes to replace the previously used groundwater for agriculture, and there desalination comes into the picture to basically provide additional water and allow agricultural production to become more substantial than it is at the moment. In terms of desalination, a few points. The energy supplied to enable the desalination will come from renewable energy, and there will be general effort to minimize impact from the energy as well as the water generation technologies. And more importantly, in the agriculture demand side, again, as was highlighted in the previous speech, there's a very strong emphasis on water use efficiency to maximize the benefit from every drop that is being used in agriculture. In terms of design, there is a requirement, obviously, for an infrastructure to be built and a functioning system that needs to result out of the planning. This has to be compatible, however, with the sustainable development goals in terms of also engaging in economic diversification activities. So there are a number of guiding principles for planning, and as the chairman explained this morning, QNFSP at this stage is developing a master plan, not building infrastructures yet. So over the next 2 years, the master plan will be finalized. And there are a number of issues that are very important. One thing is that there is focus on technology neutrality, and the other one that technology selection is based on clear performance orientation to enable the design of a system that can improve over time and adopt the latest technology at each step. In terms of the main infrastructure elements, these are solar parks to basically host the solar power generation infrastructure. The electricity grid is an important element, as well as seawater desalination plants on the water side and aquifer recharge and reuse. Now, I just want to explain to you a few interactions on these systems. What we have done, we have modeled the infrastructure to be able to explore its performance and play what-if scenarios and learn lessons in terms of policy development, since QNFSP will yield policy regulation and possibly also new legislation. In terms of the problem, we have a systems problem, so we deal with multiple systems that are interacting. We have a water that goes into agriculture, there are interactions there. We have energy going into water production, there are interactions on that side. At each level, there are advanced technologies that are fast changing. For example, in desalination, technologies are emerging. In solar energy, many technologies are emerging and improving. And in the end, the goal is to have an efficient system overall. So what we developed is a model that can capture different dimensions of the problem, different forms of clean energy, different technology types, desalination, and also the interactions with the groundwater, with the farms, and also with the energy grid. In terms of illustration, we will illustrate it with a combination of CSP for solar, RO for desalination, aquifer storage, and the demand from the farms. There are multiple systems here. There are the power system, so electricity, the heat system, as well as the distribution of water between the different entities. And a number of dimensions are being considered, including the emissions that come out of the different scenarios, as well as the input data on solar radiation and so forth. Just some screenshots. So if we look at the standalone solar scenario, then for an integrated system based on solar with desalination, aquifer storage, there is more or less 3/4 cost on the solar energy side and 1/4 cost on water storage as well as on desalination. Now this is the standalone case which has no interactions with the rest of the country and becomes the most important, the most expensive scenario. If we compare that against the case where instead of solar, gas is being used for the energy generation, then we see that the gas-only scenario costs significantly less than the solar scenario, which is expected since solar energy is fairly costly compared to fossil fuel. Now, in terms of seeking synergies with a balanced approach towards energy, more active energy management with the electricity grid, there can be cost savings in the form of synergies as you integrate the solar power generation with the normal power generation. The solar can help in peak shaving in the summer, and a more active demand management on the desalination side can also achieve further savings. So in terms of the cost estimates, they are on the high side here, so we have used very high estimates for solar, especially more realistic cost estimation is the dotted box here, which still is significantly more expensive than the gas. Once you have a model, obviously you can also play some cases on the cost of gas. At what point would you break even between the solar and the gas, as well as on the planned lifetime of solar, what difference it would make to the economics of the system. In terms of analysis also, it is possible to quantify benefits that can happen elsewhere in the infrastructure, which may be outside of the core QNFSP system, and span into more the general electricity generation sector. So it's important, again, to design a system that actually realizes benefits overall, rather than at the local level is very efficient. With that, I go back to the sustainability matrix, because the infrastructure is only one part of the program, and there's another part which is the development of technical industries and service industries around the sectors of water, energy, agriculture, and food. And there are significant challenges ahead. The general philosophy is that there are many technologies, there are many opportunities across the areas. There may be opportunities in solar energy, there may be opportunities in water technology, there may be opportunities in agricultural technologies that can be exploited on the back of a major program such as QNFSP that will result in significant infrastructure investments. The goal is to basically not export food as a result of the program, but to export know-how in different shapes or forms. Okay. Almost done. So there are multiple dimensions that need to be analyzed here. This is not a trivial task. So there are economic considerations, both locally as well as internationally, for the different technologies and their integration with ongoing economic activities. There is a need to understand the implications of educational and R&D requirements to be able to master different technologies. There needs to be a clear understanding of maybe not competition, but ongoing activities in the region to avoid duplication. And there is the challenge of integrating technology that bring opportunity in the future into an infrastructure in order to be able to accelerate developments. There's a myriad of choices. This is just some tree of different technology and component choices that are relating to solar energy for CSP. So you have different technologies, there are different components, and the question is, where is the opportunity that can be packaged up with other opportunities elsewhere to yield significant benefits in terms of economic diversification. There are also multiple value chains in involved in the different technologies. There are material flows that go across the different sectors. They all need to be clearly understood in order to develop a strategy on the back of the economic diversification goals that span across energy, water, agriculture, and food. In terms of provisions in the infrastructure planning, there are two very important aspects. There is technology neutrality, to be able to not commit an infrastructure to a certain technology choice, and the other one is to have a very clear benchmarking of performance to understand which improved technology can actually enter into the existing infrastructure. With that, I conclude, and I would like to thank you and hand over to the next speaker.
Thank you very much. Thank you. Thank you, Dr. Patrick, for your constructive presentation. Now with the next speaker, I'll be handed over to you, please.
Okay, he's here. Our next speaker is Mr. Gunman, and he's going to talk about water security versus agricultural production, a new way for an optimal and sustainable management of resources under arid conditions. I would like you, Mr. Gunman, to introduce yourself as possible. I don't have your CV. Huh? ما عندك CV.
This one? Yes. This one? Yes. Thank you. You are the guy who I'm looking for. Sorry? Okay.
Can you introduce yourself, Mr. Gunman?
Sorry?
Can you introduce yourself, please?
Okay. Yes. Good evening, ladies and gentlemen. Good afternoon, sorry. My name is Dr. Jens Grundmann. I'm from the Dresden University of Technology. Maybe we can see it. Oh, no, we don't have the slide. Okay. I did my PhD in hydrology in the field of uncertainties of hydrological models. And now I'm working in a project which aims on a integrated water resources management. We develop new tools for a sustainable management of resources like water and agriculture. And we have a project together with the Ministry of Agriculture and Fisheries and also the Ministry of Water Resources and of regional municipalities and water resources of the Sultanate of Oman. And this is my talk about, and I will, oh, yes, now we have the slides, thank you. And I will introduce a new way for an optimal and sustainable management of resources under arid conditions to you. This is a short outline of my talk. At first, I would like to talk motivation and objectives. Then I would like to introduce the new tool, sustainable management and resources for you. I would tell you the structures, modules, and then I would like to go a bit into more details against water resources, agriculture, and management, some implementational steps, and finally a summary and conclusion. As we already know, the water situation in arid regions is quite tight. Some of the natural systems are overused and out of their natural balance due to an increasing water demand of water for water supply and irrigated agriculture on the one hand, and on the other hand, on a limited water availability of the natural resources. One example for such an unbalanced system is the Batina region in the Sultanate of Oman, where excessive groundwater abstractions due to irrigated agriculture yields to an inversion of the groundwater's natural gradient and therefore to an intrusion of marine salt water. Therefore, the water for irrigation got saline and also the soils, and this leads to a destruction of valuable agricultural resources, which implies a decreasing farm income and also a lot of abandoned farms, like you can see on the figure below. And considering the fact that the Batina region is the center of the agriculture in Oman, where the most valuable soils are located, you can imagine that this fact also impacts the food security of the country. To improve the situation of the coastal area, the main objectives of our research is to develop and implement an optimal integrated water management and long-term planning system for water quality and water quantity. And this is which allow for a sustainable management of water and soils together. Yeah, this implies a balancing of water demand and water availability, and also an improvement of the water use of the irrigated agriculture by novel irrigation techniques. Here in this figure you see also our study area. It emphasizes the Wadi Karus, Marwil and Tau. And the challenges that we have is that we deal with a coupled dynamic agricultural coastal aquifer system, which requires a sound description of the interacting processes. And of course, we deal with climate and global change, which also requires models which are able to predict these changes for the future. Now, okay, how does our system look like? It consists of an assessment part for water resource availability and water demand. Thereby we focus on the main resources, the groundwater resources, and the main consumer, the agriculture in this phase. Prognosis for future climate scenarios can be driven, and these also drives an optimization and management tools which aims for planning and management issues. Management issues of such a technical system that we have here, that is like aquifer pumping and artificial aquifer recharge. All these together we call the APPM, the Assessment, Prognosis, Planning and Management Tools, and this is a scientific tool on which we work. But without an implementation, it's only a toy, and therefore we are very glad that we have such a good cooperation with our Omani partners from the Ministry of Agriculture and also from the Ministry of Water Resources regarding the field of monitoring, socio-economic development and decision making. Today I'd like to focus on some points, some main issues of the system. I would figure out some main tools in the fields of water resources, agriculture, and also the optimization, which shows how both modules are interacts together. Okay, this is a vertical slice of our project area. You see on the right hand, on the right side the coastal region, and on the left side the mountainous area. And of course, the aquifer plays a very important role in this system. And to portray the coastal aquifer adequately, we built up a three-dimensional density-driven groundwater flow model for simulating the aquifer behavior, inclusive the saltwater intrusion phenomena based on the OpenGeoSys software. And the big one is a three-dimensional model, and you see different slices of salinities, values, which demonstrates the proceeding saltwater intrusion front. As a precondition of this, it was necessary to develop a hydrogeological model together with our colleagues of the Ministry of Water Resources for this coastal aquifer. This aquifer is recharged in two ways. One way is the surface runoff and infiltration. And to simulate these processes, we use a model chain, which consists of routing models with infiltration, recharge dam simulation model, and a Wadi channel routing model based off a hydrodynamic code. It's a zero inertia model, which allow to consider the most important runoff characteristics of ephemeral streams, like Wadi and dry riverbeds and standing waves. But the most important path for groundwater recharge is this subsurface runoff, the recharge at the mountainous front. Because the most of the rainfall occurs in the mountains. It's around 350 millimeters per year, and in the coastal area we don't have so much rainfall. It's around 50 to 100 millimeters per year. But such a vertical slice is only one side of the medal, and even if we look on the geology, We have here areas which are more permeable than others. Like you can also see, not only from the geological map on the right side, but also from the from the isotope map on the left side. And therefore, the common assumption that the subsurface and surface catchment divide are the same will fail in this region. Considering this, we developed a GIS-based approach for spatially distributed recharge rates based on the geomorphological variables. In the upper left figure, it's left one from your side, yes, you see how these recharge rates differs regarding different geomorphic variables like height, slope, and lithology. And together with the annual rainfall map, it's showing below, we can derive by the help of such a fuzzy approach, we can consider by the help of such a fuzzy approach the different opportunities for groundwater recharge rates at the mountain front. This means with such a procedure we have the ability to estimate potential ranges of freshwater availability, and we call this procedure straightforward approach because it's a simply application of models following the way of the rain. With this approach, we achieve values between 60 and 73 million cubic meters per year, and we validate this approach against an inverse modeling approach using the groundwater model, and by performing a steady-state calibration of the groundwater model using optimization methods. And like you can see, we are in similar ranges, and this underlines also our hypothesis that of the uncertain subsurface catchment divides in this region. Second issue, the assessment and planning of agriculture, assessment and planning tools for agriculture. Sorry? Oh, okay, I will go roughly through this. Sorry? Due to my introduction, sorry. Okay, so I will go roughly through the slides. The task for researchers was already defined, more crop per drop by the UN World Water Report, and this means to increase. This means an increase of crop water production by decreasing water demand for producing the same amount of food. And increasing water productivity requires an optimal scheduling and control of irrigation systems. And to achieve this task, we have two options. Either we carry out a lot of experiments for different combination of soil type and climate, or this is the way what we do, we perform only a little amount of irrigation experiments which are intensively monitored, and then we use the help of models and optimization tools to identify the most beneficial irrigation schedules and apply them on the field back. The underlying methodology is called occasion. It offers basic tools for assessment, planning, and management. Some main parts of these are irrigation experiments, validated SWOT models to transfer of experiments in space and time, optimization tools which gives the best layout and scheduling of the cropping pattern, and of course Monte Carlo simulation which offers a high reliability of irrigation management under climate and soil variability. The main output is such a crop water production function which describes the relationship between the potential yield and the seasonal applied water. And as you can see, it's a nonlinear function, and therefore it offers also the opportunity to save additional water by applying such deficit irrigation methods. If we apply Monte Carlo simulations for different weather scenarios, we can derive such a stochastic representation of the crop water production functions from which you can get values of how much water is necessary to achieve a certain yield with a certain reliability, which makes also the agricultural schedule or the schedule for the irrigation more secure. From these, we can also derive the irrigation schedules, and by transferring them into a more understandable way for the farmers, like here shown below, such irrigation schedules, or in such a microcontroller system, we have the opportunity to apply them also to the farmers. Last issue, optimal management of coupled hydro system. It's the way how we can manage the interacting groundwater and agricultural systems, sustainability regarding water quality and quantity under uncertain global change impacts. The main challenges here is the long simulation times of the complex and the complexity of the physically based models, as well as the optimization procedures. And as you have seen, we need such complex models, but they have these long simulation times. And therefore, we go a stepwise approach. We develop such appropriate surrogate models. These are models which allow to describe the most important state variables. Therefore, we use so-called neuronal networks to describing the groundwater model. And in the other case, we use these crop water production functions, but we expand them by a second dimension, including the salinity. Furthermore, now we have very fast models, and we can put them into a simulation procedure. This is a procedure how we can optimize water resources and agricultural modules together. And I don't want to go into details, but it is allow for optimizing cropping pattern, water demands, and also the agricultural as a cultivated area together. If we think about optimization, we have to be aware about the different management objectives like groundwater. Maybe the objective for the groundwater is that we have a long-term availability of water resources with water of a good quality. And for the farmers, the objectives might be that they want a high profit, low costs, and the high quality of their products, and therefore they need also water with good quality. But at the end, both objectives are contradicting, because if the farmer wants a high profit, he needs much more water, and this worsens the situation for the aquifer. So the main question is how can we find the best compromise between the two objectives, even if this decision depends on the actual preferences of the decision makers. And therefore we have a method, it's called multi-criterial optimization, and this is about the evaluation of such Pareto optimal solutions. Here we can see the contradicting objectives in the objective space. We have the one end of the objective functions, the long-term profits. We have on the other end the long-term sustainability. And in between, we have different optimal such compromising solution, which we call multi-objectives. And along this line, you can move and find adequately solutions for this problem. This is the output of such a system. We achieve cropping pattern abstraction rates, the cultivated acreage salinity of the irrigation water, irrigation schedules, of course, for the farmers, the profit for the farmers, salinity of the aquifer, water levels of the aquifer, and this allows us to perform a cost-benefit analysis for the stakeholders, because we take the economic aspects like the costs and the revenues for the farmers into consideration. I don't want to go much in these figures. And yes, I would like to conclude. As I already thought, we developed a tool, and this tool is only one point in the long process to implement all these things. But we already started in this way. We had a couple of workshops. We had an e-learning and a first application of an e-learning tool. We developed a capacity development plan. Such guidebook is under development, and we hope that we have soon a pilot farm project together with the Ministry of Water Resources and the Ministry of Agriculture. Of course, we perform experiments in the frame of the agricultural research of Oman. I would like to skip this, and I would like to thank my co-authors, the Omani ministries, for their nice cooperation, and also the Ministry of Education and Research of Germany for funding us. And sorry for being a bit late, and if you are interested in more details, you can read one of our papers. Thank you.
Thank you, Mr. Goldman. I think if you can take the seat, and I call upon the other speakers, please, to come on the stage. And I'll open the floor for a few questions, please. يلا وليد. أمي أول. The first question, Busami. Do we have microphones here, please? Here.
Here. Test.
هذا good.
Thank you very much, Mr. President. First of all, I would like to thank all speakers of this morning session and this also completing sessions. I have only a comment, Mr. Chairman, and not a question. And this concerns this morning 3 speakers, namely Mr. Fahad Al-Atiyah, Dr. Khalid Al-Ruwais, and Dr. Walid Al-Zubari. لقد تحدث الإخوان الثلاثة بإسهاب جيد وارتاح الجميع لما سمعوه لهذه الثلاث أوراق التي قدمها الإخوان الثلاثة. ولا شك أن هذا موضوع مهم جدا تطرق إليه الكثير من الزملاء في مؤتمرات سابقة، سواء من الأول حتى العاشر. وقد شاهدت بنفسي معظم إذا لم أقل كل هذه المؤتمرات التي عقدت من قبل جمعية علوم وتقنية المياه في جميع دول مجلس التعاون. هذا لا شك أنه موضوع هام جدا، وهو المتعلق بالطاقة وإنتاج الغذاء، وكيف نحافظ على إنتاج هذا الغذاء وما تستهلكه دول المجلس وما تستورده من هذا الغذاء. ملاحظتي الوحيدة هي ما يتعلق بالlegislations لهذا الإنتاج وهذا الاستيراد. نحن في دول المجلس نستورد كثيرا ولا ننتج إلا القليل. المشكلة لدينا هي عدم توفر القوانين اللازمة حول الإنتاج والاستيراد كذلك. وما أود التركيز عليه هو أن نؤكد ونركز على القوانين التي يجب أن تحكم هذين الفئتين. وشكرا.
شكرا أخ عبد اللطيف. السؤال هو مو بسؤال، كومنت موجه إلى الأخوة. في أحد عنده جواب أو تعليق على الموضوع؟ خالد. ممكن تيجي على
شكرا دكتور. صراحة كلام جيد، لكن احنا بلدنا تعجب القوانين والأنظمة، خاصة في عملية الاستيراد والإنتاج. لكن المشكلة بوضوح وبكل بساطة إن عندنا قدرة شرائية عالية جدا، عندنا إمكانية الاستيراد، عندنا إمكانية الإنتاج، لكن عندنا محددات اللي هي مورد المياه بالذات. فبالتالي ما عندنا خيارات، لا بد أن تصير الخيارات مبنية على العائد الاقتصادي الحدي لأي متجه نقدر ناخذه، سواء للاستثمار أو الاستيراد أو للإنتاج المحلي. واضح أن العائد الحدي لوحدة المياه عالي جدا من ناحية الإنتاج، فما نستطيع أن ننتج. لكن قضية الأنظمة، أنا أتكلم من واقع المملكة العربية السعودية، أنظمة الاستيراد أنظمة واضحة جدا ومشجعة، سواء للمصدر أو للمستورد السعودي.
شكرا. أعتقد عند الدكتور تعقيب هي.
Chairman, essentially my question is to the last speaker. We know that the problem of groundwater management in Oman is the over-abstraction, over-pumping. So if you can please explain how you are going to address this problem of monitoring the groundwater. The second question is related to the efficiency. You are talking about sensors, and if you can also give us an idea about the efficiency improvement when you use modern sensors at the farm level. Thank you.
Sorry, I did.
Okay, speak. Just speak.
Sorry, I didn't understood the first question. Please, can you repeat it again? But during this, I like to answer the second question. We use sensors which measures the soil tension and the soil moisture in a very detailed way in a time resolution of 50 minutes. And we use this to control the amount of irrigation which comes into the soil, that the water is only goes to the main root zone of the soils. Yes, and these are sensors which are still available. And by these sensors, we are able to calibrate our models. These are models, SWAT models, soil vegetation atmosphere transfer models, which describes which describes the behavior of the plant growth and also the distribution of the water in the soil. Yeah, it's called, and by the help of these models, we can use them to find out what are the best schedules and what are the best irrigation times, how long we have to irrigate, what are the durations between the different irrigation, because these values depends highly on the soil hydraulic properties of the soil. If you have a sandy soil, you have to irrigate quite often with very less amounts, and if you have a soil which is more, which has more loamy, yeah, you can irrigate more and per one event, yes, but you don't need to irrigate quite frequently.
Yeah.
I'll take two more questions, please, because of time. You can discuss it outside, please. I'm sorry for this. I have Mr. Muhammad here. He raised his hand, and I have Dr. Nader. I'm apologizing really for, I know there's so many questions, but the problem is time is very short. I have no time. We need to finish this session, going for a coffee break, and then we come back again. Mr. Muhammad.
السلام عليكم. أولا أحب الحقيقة أشكر الأخوان في دولة قطر على حسن الضيافة والتنظيم، وأكرر شكري كذلك للجمعية. أولا يعني أردت أن أتكلم باللغة العربية حتى الحاضرين من الديسيجن ميكر يعني يعتقدون أن هذا الوضع الحالي في الدول العربية عموما والخليج خصوصا في القلق المبرر من قضية الأمن المائي. وكما شاهدت هذا الصباح يعني حديث أصحاب المعالي عن القلق من الأمن المائي، وهو حديث مبرر الحقيقة. نجده وهو للأسف الشديد يصاحب بقلق أكثر حدة، وهو القلق الأمن الغذائي، في حين أنه لا يمكن، يعني نعتقد مثلا على سبيل المثال كما أشارت الأخت سلمى 80% من المياه الجوفية في مملكة البحرين تستخدم لإنتاج غذاء لا يضيف شيء بين قوسين للأمن الغذائي البحريني، في حين أن هنالك قلق عالي الشدة في البحرين عن الأمن المائي بسبب وجود الأخطار المحيطة. فمن العقل أن نضع، أنا استخدمت البحرين ولكن الصورة تماما لدول الخليج العربية، لكنها بما أنها تكلمت بأرقام يعني مباشرة. لو اختير، ومعذرة على الكلمات، لو اختير أن يوقف الزراعة تماما في البحرين، كمية الماء التي توفر في سنة واحدة كافية للبحرين لمدة 8 سنوات لمياه البلدية. طبعا هذا الاختيار يسمونه راديكال، لكن with a very good management system you can go from يعني non-sustainable food security already there and to more sustainable water security. فأنا أعتقد أنه من الأولى أولا قبل وضع الأمن المائي كإشارة واضحة أن نبحث ماذا نستخدم من الووتر ريسورسز أو المياه الجوفية اليوم في دولنا، ونجدها يعني بتحليل بسيط نجدها كافية جدا لتحقيق الأمن المائي. وأشير دائما وأكرر أن الأمن الغذائي هي it's a global issues ولا هي set local issues. شكرا.
شكرا أخ محمد. في تعليق من الأخوان؟ أنا أعتقد
بغيت أقول شغلة واحدة بس، يعني المقارنة أنه نوقف الزراعة ونوفر المياه البلدية غير واردة أنيمور في البحرين، لأن المياه الجوفية مالحة جدا إلى درجة 2000 ملغ بر لتر لا يمكن استخدامها. فهي بس حبيت أقول أنه هو صح هذا الكلام يمكن 10 سنوات، بس الحين وصل إلى مرحلة نحن we cannot use the groundwater for anything for this يعني except for blending with the desalination. بس أخوي يعني قاعد يقول لي نفس الشيء، يقول لي هل هم متعارضين الأمن المائي مع الأمن الغذائي؟ هل هم متعارضين ولا هم متوافقين؟ أنا أقول له في منطقتنا يعني هم متعارضين، لأن عشان تحقق واحد لازم تاخذ على الثاني. فمثل ما تفضلت it's a global issue, it is not a local issue.
I totally agree, but the more important, I agree to the point which that we need to change the rules and regulations. It's not anymore business as usual. If we change our attitude, then we can do something.
عندي سؤال أخير دكتور نادر إذا ممكن بس تختصر الله يخليك، لأن خلاص time is over.
Thank you very much. I think what I wanted to say was just mentioned by a friend. I was going to say that yes, food security is very essential, it's important, but we should not think of providing food security by developing the agriculture in our own individual countries necessarily. If we have shortage of water, we're in a desert area, we should, I think, look at integration. The whole world now is one village, right? Why shouldn't we, as part of food security, not invest, say, in a place like Bangladesh? They have floods every couple of years, thousands of people die. Maybe we should invest in technologies to store that water and use it throughout the year to provide the food that we need in other countries. And this way we solve their problem and we solve our problem.
Can we have a quick answer, please? Who's going to answer here?
Okay.
Okay.
So I will answer, since it's the last question. No, I think you make a number of valid points there. So there is not a black and white solution that can be sought to the problem. The domestic production is only one angle. There are other angles, including strategic reserves and also the coordination of food sourcing on the global markets that leads then to models, as you described, to create win-win situations elsewhere in the world as a result of the investment coming from here. So these dimensions are being planned for, and the domestic production typically receives the most attention because it has high-tech elements. It is growing food into scarce regions, but the other two dimensions are as important as the domestic production as well.
As to my knowledge, after the 2008 food prices increase, all the GCC countries have already invested outside, and they have bought farms either on a long-term lease or renting. In the last report of the Economist Intelligence Unit, they have put actually the numbers and how much has been invested outside, but they have warned about one very important thing, that the local people are not benefiting from these projects, and you have to be very careful in the future when you go outside and you invest in a country like Thailand or India or Sri Lanka without giving the local people the benefits. There should be a mutual benefit, and instead of making deals with the officials, you should make some local partnership there.
Also, we declared, King Abdullah declared his initiative for agricultural, Saudi agricultural abroad. We encourage this kind of investment.
Well, on your behalf, ladies and gentlemen, let's thank our speakers here. And I would like to present some certificate for the new speakers who came on stage. And please, we are going for a very short break, coffee break, and we'll reconvene. Please, 10 minutes if possible. Only 10 minutes, please. Thank you very much.